Welcome to another video in this series, Statistics using R. Today we will learn covariance, that is the definition of covariance, the necessity of covariance, computation of covariance by hand mathematically, and then we will see the command of covariance using R. So let's start.
So we represented dependent variable y in terms of a function of x, the independent variable. However, we often are not interested on prediction. Rather than predicting, we often are interested predicting means predicting the variable y, which is dependent on a variable x. That is, we are given a variable, given a value of x, we want to predict a value of y. This was the situation for regression analysis. But most often, where we do not want to predict a variable from the other variable, rather both of the variable are known to us, like x is known to us, y is also known to us, both of them are known to us, and then we want to find a relation between x and y. We do not want to predict y from x, because prediction means we do not know the value of y, we know only the value of x. But in this situation, the current situation that we are going to talk about today, both of the values x and y are known to us, and we want to get a mathematical relationship or a graphical relationship between x and y, whether we can find a strong relationship between or association between x and y. This cannot be done through regression analysis. Rather, we have to invent or we have to study another topic on that. So consider a situation. Here we have taken an example. A serum cholesterol is an important risk factor in the etiology of cardiovascular disease, and several research work has been devoted to understanding the environmental factors that cause the elevated cholesterol levels in our blood. Now, for this purpose, cholesterol levels were measured on 100 genetically unrelated spouse pairs, then husband-wife pairs, and they are genetically unrelated, means they are taken from different families. 100 measurements have been taken. And here in this context, we are not interested in predicting the cholesterol level. Given a husband's cholesterol level, we do not want to predict the cholesterol level of his wife, or the vice versa, right? We cannot predict something from here. Rather, what we want to study from these 100 spouse pairs is there any quantitative measure relationship, quantitative relationship between, say, the cholesterol level in husband's case with the cholesterol level in the wife's case. So we will use the correlation coefficient for this purpose. So this is the new term that we are going to study, is the correlation coefficient. See here, what this graph shows that we can put cholesterol levels of 100 husbands here, and their pair wife here in the y-axis, and we can have a curve like this to all the husband wife points, like x points and xy, all the xy points. Does this curve suggest anything mathematically? This is what we're going to study through correlation coefficient. uh, Very few topics today. The background that we have studied, the meaning of correlation, types of correlation, what does correlation coefficient means, how do we calculate correlation coefficient, range of the correlation coefficient, interpret the correlation coefficient, and then their relationship and difference with regression analysis. First, and the only thing that we need to know before going to correlation is the covariance. Covariance, you know the what is variance. It is the square of standard deviation. You know how to calculate variance. Then what is the covariance? Covariance, simply, if you do not go through the mathematical detail, but the first thing that stuck to our mind, what is covariance? Covariance can be, or can only be one thing, that is covariance means two variables x and y, how they vary together. This is the mathematical equation for covariance, where covariance between x and y, two independent variable, is E means the expected value. And mathematically, wherever we say expected value is nothing but their mean. So average. So here expected value, which is x minus mu x into y minus mu y. Mu x is and mu y are their mean. Exy means here these can be rewritten as exy minus mu x into mu y. Mu x is the average value of x, obviously. Mu y is the average value of y. What is exy? Exy is the average value.
To compute the covariance for population and sample, we will use these two formula. For population, it will be summation of xi minus mu x into yi minus mu y, where mu x mu y are the mean, by n. N is the number of elements in the dataset. See, the population includes all the elements, and a sample consists of one or more observation from the population. So in case of sample, the formula will be xi minus mu x into yi minus mu y by n minus 1. For sample, it will be n minus 1. For population, it will be n.
So here we have taken an example where we will compute covariance between two variables GRE and GPA using this formula: GRE I minus mu of GRE into GPA I minus mu of GPA by n minus 1, where mu GRE and mu GPA are the mean of GRE and GPA variables. GRE I and GPA I are the ith occurrence of GRE and GPA. So let us compute the covariance with these data of GRE and GPA. I have taken 6 data from GRE and GPA from 6 students. So first we will calculate a variable A, which is GRE minus mu of GRE, because we have to calculate this for every I. This is summation over I. So for every I we have to calculate this. So let us calculate this A, GRE minus mu of GRE. So what is the value of mu GRE? First we need to find out. For that we need to find out the summation of this summation of all these values. I can find summation of all these values is 3760. You can use calculator to find out that. What is the value of mu GRE? Mu value of GRE is then 3760 by 6, which is 626.67. Similarly, summation of GPA will be 20.4, and 20.4 by 6 is nothing but 3.4. So that is the value of mu GPA. Now I will find these individual values. So 380 minus 626.67 will be minus 246.67. Similarly, I can proceed with the all the other values. It will be 33.33. This will be 173.33, 13.33, 520 minus this, again a minus figure, 106.67, then 133.33. Similarly, I have to compute B, that is 3.4 minus 3.61 is 3.61 minus 3.4 is 0.21. This will be 0.27. 4 minus 3.4, 0.6. 3.19 minus 3.4 is minus 0.21, minus 0.47, minus 0.40. So these are the values that we have computed for A and B. Now finally the covariance then will be summation of this GRE I minus mu GRE. This is my GRE I minus mu GRE into this. So A into B. I have to do A into B. So what is the value of minus 246.67 into 0.21? This will be minus 51.8. This will be 9.0. This will be 104.0, minus 2.8, 50.13, minus 53.3. This is 55.2. Summation of AB is equal to this. Now then what is the value of this 55.2? So now covariance of GRE, GPA is equal to summation of this figure is 55.2. So this is 55.2 by, see here, n is equal to 6. So n minus 1 is nothing but 6 minus 1. So this value will give you 11.04. That's the answer for sample. If this was population, then it would have been 55.2 by 6, which is 9.2. This is for population and this is for sample. Now, can we compute covariance using this formula EXY minus mu x into mu y? We can do that as well. Here, this is my mu x and this is my mu y, 626.67 into 3.4. What is EXY? For EXY, I have to compute GRE into GPA. So, what is the value of GRE into GPA? Let us compute first GRE into GPA. Here I will write GRE into GPA. So these are the values that I can get: 1371.8, 2422.2, 3200, 2041.6, 1523.6 and 2280.0. And if I take summation of this, it will be 12839.2. So this value, summation EXY minus mu XY, will be, this will be equal to 12839.2 by 6 minus mu x into mu y, 626.67 into 3.4. And if you calculate this, it will be 2139.867 minus 626.67 into 3.4 will be 2130.667, and will eventually will get 9.2. So that will be for population. So whether you compute using this formula or that formula, you will end up getting same result for population, but for sample you have to find only n minus 1.
We have seen how to compute covariance using mathematics, that is using now we will see how to compute covariance in R. I will take the same data for, that is GRE and GPA. So I have taken this GRE and GPA in two vectors. The formula for covariance of the command for covariance in R is POV, and then it will take the two variables, that is x and y, here GRE and GPA, and the result will be 11.04. Now we will see some properties of covariance. It can be shown that if two random variables x and y are independent, then their covariance will be 0. Wherever if large values of x and y tend to occur among some number of samples, then the covariance is positive. Whereas the reverse case, if x and y, if small values of x and large values of y, or large values of x and small values of y tend to occur among some subjects, then the covariance is negative. It is something like you have this kind of graph. If x is large in some samples and the values of y is also larger with the increment of x, this is called positive covariance, where if the values of x is whereas if the values of x getting larger and if the with the values of x getting larger, the values of y getting smaller, then the covariance will be a negative covariance. So these are the type of covariance. And if there is no change with the increment of x, there is no change in y, then I can create a graph like this where it will be a zero covariance. An issue with covariance, one issue is that the covariance between two random variables x and y is in the units of x multiplied by the unit of y. So this is difficult to interpret the strength of association between two variables because the magnitude of the covariance is a result of multiplication of the units of x and y. So the magnitude does not tell us any story. So to obtain a measure of relatedness or independence of x and y, we have to consider anything other than covariance. So in the next video, we will see how to deal with this problem, that is the magnitude problem of covariance, and then we will introduce into the correlation coefficient.